Welcome to this explainer, where we are diving headfirst into the absolute quest for power. If you've ever wondered exactly how engineers manage to squeeze such massive amounts of power out of an internal combustion engine, well, you're in the right place. Today, we're taking a deep dive into the incredible mechanics of forced induction, specifically how a supercharger actually works.
I mean, seriously, how do you just bolt on literally hundreds of extra horsepower? It sounds like pure magic, right? But it's actually just physics. Think about your standard Ford F-150 rolling off the factory lot. On its own, it's a perfectly capable truck. But as the folks over at Town & Country TV highlighted, by bolting on a specific Roush performance unit, you can transform that exact same truck into a 705 horsepower monster. So, how does a single piece of hardware achieve such a mind-bending increase in performance?
Well, here is our roadmap for today's explainer. First, we'll unpack the secret to massive horsepower. Second, the three main ways to build a boost. Third, we'll get into the gearhead math of tuning pulleys for more power. Fourth, we'll cover what to listen for when your supercharger is running. And finally, we'll look at the future of forced induction.
All right, Section 1, the secret to massive horsepower.
To really wrap our heads around a supercharger, it helps to remember that an engine, at its very core, is basically just a giant air pump. The fundamental rule of making power is pretty simple. More air plus more fuel equals a much bigger explosion. A supercharger acts as a massive air compressor to make that happen. Air is drawn into the inlet, and these internal blades rapidly compress it. But there is a catch here. Compressing air generates an intense amount of heat, so right before that hot air hits the engine, it passes through an intercooler to drop the temperature. That ensures a highly dense, oxygen-rich, and cooled charge of air is forced straight into the cylinders.
Now you might be wondering, okay, how is this any different from a turbocharger? Well, a turbo relies on the engine's hot exhaust gases to spool up and create a spinning motion, and that process inherently takes time, giving you what we call turbo lag. But a supercharger, it's mechanically belt-driven directly from the engine's crankshaft. Because it's physically connected to the crank, the exact second you plant your foot on the accelerator pedal, you get an immediate, visceral throttle response with virtually zero lag. It is instant power.
Moving on to Section 2, 3 ways to build boost. There are basically 3 main flavors of superchargers out there, and they each have a totally distinct personality. First up is the Roots blower. It's old school, reliable, and delivers instant boost, but it relies on external compression, meaning it essentially just moves air into the manifold without compressing it internally. Because of that, it has lower efficiency and generates a lot of heat. Next is the twin screw. This one's a bit more complex and expensive, but it actually compresses the air internally between 2 intermeshing rotors. That gives it much higher efficiency and only moderate heat generation. Finally, we have the Centrifugal Supercharger. This guy operates dynamically, kind of like a turbo, using a high-speed impeller. It's incredibly efficient and compact, but the boost is entirely dependent on engine RPM, so you don't quite get that same instant low-end punch. For a perfect example of a modern engineering marvel, just look at the Eaton TVS R-Series Supercharger. The internal rotors inside that housing are incredibly complex. This is a highly advanced positive displacement unit that truly pushes the absolute boundaries of airflow.
TVS stands for Twin Vortices Series. Manufactured by Eaton, this tech took traditional Roots blower designs and totally revolutionized them. Instead of the older, simpler lobe designs, TVS uses twin 4-lobe rotors featuring aggressive 160-degree twists. It is frankly fascinating how that specific geometric twist smooths out the airflow and massively improves the efficiency curve. It's exactly why you see these specific units stuffed under the hoods of everything from high-end Jaguars to massive performance Fords.
All right, Section 3, tuning pulleys for more power. 2,650. Think about that number for a second. In the case of the 2.65-liter Roush unit we talked about earlier, that number represents the cubic centimeters of air compressed and pushed into the engine for every single 360-degree rotation of the supercharger's pulley. That is a truly staggering volume of air being forced through per revolution. So, once you have that hardware bolted on, the really crucial point comes down to gearhead math, specifically the pulley ratio. It's the crank pulley diameter divided by the supercharger pulley diameter. If you want that supercharger to spin faster and force in even more air, the simplest way is to shrink the denominator of that equation. By bolting on a smaller supercharger pulley, you increase the overall ratio. A smaller pulley equals a faster spin, and a faster spin equals more boost.
Our source at Town & Country TV points out the massive temptation here, saying if you wanted to get gutsy and you wanted to completely load up on the horsepower, you could get more rotations out of the supercharger by adding a smaller pulley. But hey, a quick warning if you buy a complete kit with a factory warranty, do not touch that pulley. Manufacturers use specially marked bolts on the front of the supercharger to tell if you've been tampering with it. If you swap that pulley just to squeeze out a bit more power, they will absolutely know and it will instantly void your warranty.
Which leads us to Section 4, listening to your supercharger. Because compressing all that air, it puts immense mechanical stress on the hardware. 18,000. That is the RPM these internal components can spin at. Honestly, anywhere from 18,000 to 24,000 revolutions per minute. Because of these incredibly extreme operating speeds and temperatures, superchargers actually require their own specialized lubricating oil that is entirely separate from your standard engine oil.
Now, if that lubrication breaks down or parts begin to wear out, which, by the way, is something technicians frequently see on vehicles like Jaguars and Land Rovers, your supercharger will literally start talking to you. You need to know what these warning sounds mean. If you hear a light, irregular rattle at idle, well, that often points to a worn coupler or isolator in the front nose drive. If it turns into a continuous, high-pitched whine or a grinding noise, you're likely looking at bearing wear or a total lubrication breakdown. But if you hear metallic scraping, stop the engine immediately. That means severe bearing failure has allowed those fast-spinning internal rotors to actually contact the housing, creating metal debris and destroying the unit from the inside out. Not good.
Let's wrap up with Section 5, the future of forced induction. So, what's the next massive evolution? Well, researchers at the University of Bath have been analyzing this really cool variable drive centrifugal supercharger system known as V-Charge. And it solves a major problem with older designs. See, traditional fixed-ratio superchargers constantly drain engine power. We call it parasitic loss, even when you don't actually need boost. This requires complex clutches and bypass valves just to manage all that excess air. The V-Charge system fixes this by utilizing a Turbocharger continuously variable transmission, or CVT. This ingenious setup allows the centrifugal compressor to spin entirely independently of the engine speed. With a really wide ratio spread of 10:1, this system can instantly provide the exact boost pressure needed for any given operating point. It completely eliminates the need to recirculate air through a bypass valve or disconnect the unit with a clutch, which drastically improves part load fuel efficiency and seriously reduces NVH, that's noise, vibration, and harshness.
And hey, speaking of new technology, you might have seen some ads floating around online for cheap electric superchargers. Let's debunk some internet myths right now. A real e-supercharger uses a legitimate turbocharger housing with a dedicated electric motor to forcefully spin the impeller and create genuine compression. But those cheap, fake internet superchargers? Guys, they are literally just plastic boat bilge pumps modified to act like cheap desk fans for your intake. They absolutely do not work.
The reason those fake fans fail comes down to simple physics. Compressing air takes massive energy. In a mechanical setup, 6 to 7 brake horsepower is sapped directly from the engine for every single PSI of boost generated. If you try to translate that to electrical power, a standard 12-volt car battery simply cannot replace the immense mechanical torque of a spinning crankshaft. A true electric supercharger requires a heavy-duty electrical architecture to spool up effectively, not just some cheap wire plugged into your battery.
Which brings us to our final thought for today. We've seen how simple physics allows us to bolt hundreds of horsepower onto a truck, and how cutting-edge CVT variable drives are eliminating parasitic loss and totally revolutionizing engine efficiency. So, here's a question for you to ponder. With mechanical blowers easily pushing vehicles past the 700 horsepower mark, and computer-controlled variable ratios optimizing every single drop of fuel, have we reached the absolute physical limit of the combustion engine? Or is the true golden age of horsepower still ahead of us? Thank you so much for joining me for this explainer, and as always, keep learning.